All right, everybody, welcome on in for our Math 1 class. So beginning algebra. So here we go. We're continuing with things. So I see that most of you are progressing. You want to make sure you're moving through those sections on linear equations where we don't have to go too fast. But we do need to kind of keep moving along so that we don't end up having to be rushed through some harder chapters there. So I would encourage you to keep up. I do want to just remind everybody, remember I talked about census at the beginning of the semester? That's at the end of this week, which means Wednesday and Thursday I'll be going through my classes as is stipulated in my contract that I have to do. This isn't a choice. This is the school holds us to the contract, and they take this very seriously. Anyone who has not been participating in this class sufficiently will be dropped. So basically what'll happen is Wednesday and Thursday I'm going through my classes. If I see that someone's not really participating, I have to drop them, right? I have to be able to explain to my dean why I dropped some people and why I didn't drop others, right? So if there's kind of some kind of if an issue comes up, I can say, oh, I dropped this person because of this, or I let this person stay in the class because of this. I have to be able to make those decisions and that they're defensible, that I can explain why I made the decisions that I did. So if you've been, most of you are making progress, that's great. Keep that up. But do just realize that I have to go through and drop people who have not been doing assignments and stuff like that. So, yeah, just be aware of that. So before I move ahead, how are we at? I see some people have been working on the linear equation stuff. Some people haven't gotten to that yet. Probably want to move forward. Let's see. Oops, I don't want to... let's see. Let me turn this off for 1 second. So I'll be back. I just don't want to expose anybody's emails as I switch tabs here. So if you're on the YouTube stream, you're only being blacked out for just a second here. Let's see if I go there. Okay, and we're back. I just wanted to make sure when I was switching over, I had forgotten to pull up the canvas for Math 1. And I had it open to the messages that people send me, and I just didn't want to expose anybody's messages because some people might consider those private. So let's see, we're here. So we're moving ahead. So you should kind of be on the solving equation stuff. I'll show you some formula stuff today. And then we'll be looking at ratios, proportions, and percents and continuing at that. And then you should leave a comment here in the hardest thing so far so that you're, you should read other people's posts so that when other people talk about the things they found difficult and how to fix them, you go, oh, that's a good idea. I could try to do that as well. So there's a little bit of interaction. It's not great, but it takes the place of the way you would all be chatting with each other in class a little bit and asking each other questions and stuff like that, like before class starts. Okay, and then getting into the stuff that I haven't released yet. I'm going to start releasing. We'll be to chapter 3 probably next week sometime. We'll get into chapter 3, so you kind of want to be ready for that moving forward. So you want to be as caught up on solving equations as you can. I would like to have seen a few more of you working through the solving equations. Some of you are great, right? I see some hundreds, but some of you need to move along with that a little bit. Okay, are there any questions before I move ahead? Anybody who wants to, excuse me, I'm all congested all of a sudden. Anyone who has a question that it's either a homework question or a question about the course, any kind of thing you want to ask me so that I can be helpful? No? Okay. Well, if you think of something, go ahead and throw it into the chat, okay? And then I can try to address that question, either chat. Okay, so for formula stuff, let's talk about that first. Here's the good news. The formulas, basically they want you to be able to go through and solve for a specific variable inside of a formula. The good news is you're going to use the same tools that you just did for the linear equations that we were looking at last time. where you were multiplying and dividing and all that kind of stuff. In fact, let's review one of those, right? I was going to move ahead, but let's review how we would do some of those problems, since some people are still, most of you are still working on that section of the homework. Let's take a look at an example or two of those, and then we'll get to the other stuff. But there's no point in me going over stuff that's too far ahead of people because, well, because you need to sort of get caught up first. So let me find a good example. We can review those ideas that I'm talking about, and then I'll show you how to do the same stuff, but with formulas, okay? Where are we? Here's some formula stuff that'll be good for us. Oh, and then there's two details that we didn't get to last time that I need to cover. That's right. Okay. Let's do this one. Okay, so here we have kind of a complicated equation. So let's remember the steps that we have to go through in order to solve this thing. Okay, well, our first step was to simplify both sides of the equation as much as we can. So that is, we want to combine like terms on the left, and we want to combine like terms on the right. If we just jump into adding and subtracting something from both sides of the equation, what we're going to end up doing is a bunch more steps than we need to. So we don't want to do that yet. We want to simplify both sides. So if I'm looking on the left, I see that I have some like terms. It looks, did I write that one down right? I did. Well, it looks like we have a negative 6x and a plus 6x. So what do those come out to? Right? It comes out to 0. Right? If I have 6 x's and you take 6 of my x's away, I have 0 x's left. A lot of times people think you're left with an x because they'll go, well, negative 6 and plus 6 is, those cancel out, so you're left with the x variable, right? No, remember that coefficient in front is counting it. So I have 6 x's, and then 6 x's are taken away. I don't have anything left, right? I have 0 x's. I have no x's. They're gone. I have none of them. So that leaves us with negative 16 equals, now what do we have on the right side? Well, here we have two constants. Well, those are like terms, so we can combine them. So this becomes 2x minus 4. Okay. Yep. Okay, good. I thought it wasn't going to come out right, but it is. So now I'm going to do what? Now I can start using my addition rule, which says I can add the same thing to both sides of this equation. So before I give it away, I want you to take a second and ask yourself, what should I add or subtract to both sides from this equation? Okay, so just think about it for a second. Like, just sort of choose it in your head and answer in your head or to yourself what you think the answer is. And we have some choices, but the most reasonable response would be that we should add 4 to both sides of the equation. How do I know that? Well, I have a variable term right here, and we want to undo the things that are happening to the variable term. So the variable term is having 4 subtracted from it. So what we want to do to undo a subtraction of 4 is to add 4. So I'm going to add 4 to both sides of this equation. And what that's going to leave me on the right side is just 2x now. Right? I haven't done the left side yet. But on the right side, I'm going to be left with just a 2x. Okay, so what's happening on the left? And this is where you have to be careful with your adding and subtracting, because this is a time where I'll see people go, oh, well, negative 16, if I add 4, doesn't that give me negative 20? No, no. This would be like if your bank account was at negative $16 and you added $4. So you put $4 more in your account, you're now at negative $12, right? So the answer over here, or the value on the left, would be negative 12. So that's using our addition rule. Then, now what are we going to do? Now we're going to use that multiplication rule. And it seems weird. We usually divide, but we call it the multiplication rule. But remember that division can be thought of as the inverse of multiplication. So in other words, dividing by 6 is the same as multiplying by 1/6, right? It's the same thing. So we can call it multiplication or division. We end up doing the same thing. It doesn't really matter. But what should I divide by here? So again, just take a second in your head and try to figure out what's he about to divide by? What's he going to do here? What is that step? So just think about it in your head for a second. Well, remember, we're undoing whatever is happening to the variable. So in this case, the variable that's given is being multiplied by 2. So that means I want to undo that, so I'm going to divide by 2. Or we could think of it as multiplying by 1/2. So I'm going to divide both sides of this equation by 2, and that will give me that negative 6 is equal to x, which is our final answer, except some people get nervous when it's written that way. Some people just get kind of uncomfortable, so they want to switch it around for the variables on the left, which is kind of a little bit nicer. It's a little bit easier to read, but technically we finished the problem right now when we got negative 6 equals x, but you could write this as x equals negative 6. And then we're done. And remember what you're doing, especially if you're doing the homework or just in real life, because you always want to check your answers, right? You want to, before you go out and start doing something that affects your business, you want to make sure that the value you calculated was correct. Otherwise, you're going to be losing real money, right? So you take this negative 6, plug it into the original equation, and see if the thing you get on the left is equal to the thing on the right. If so, you're good to go. Okay, so we solved that equation. We solved that linear equation. Step 1, you simplify both sides. Step 2, use the addition property. Step 3, use the multiplication property. Step 4, check your work. Okay, that's what we did. So then what's this new thing where they're talking about formulas? What's that all about? Well, basically we can take those same rules that we're using right now and we can apply them to formulas that we want to solve for a specific variable, right? So you might go, well, why would I do that? Well, depending on what you're doing, especially in science classes, anything, really even business where there's a lot of formulas that you're using, it oftentimes will save you a lot of work and energy to solve for a specific variable before you start working with that equation, right? So like maybe you're trying to calculate your retirement. So, you're trying to plan for retirement. And, in one case, you might want to solve for the amount of money that you need to invest today to have it grow to a certain amount when you retire. Or you might want to solve for the interest rate and go, what does my interest rate need to be if I want to turn this amount of money into this other amount of money? What does that interest rate need to be? Well, then you would have to solve for the different variables. But at least so far, we can just use the formulas we've already been using. So, for example, right, you're just going to use the steps that we've been looking at so far. Where's the one I wanted to use? Yeah, here's one. And here's an example, too, of why you would even do this in the first place. So let's take this formula, which says that Fahrenheit is equal to 9/5 Celsius plus 32. Okay, so what does this formula do? This formula converts Celsius to Fahrenheit. And technically you could use it to go the other way, but you'd have a bunch of more steps to do. So what you would do, right, if you're anywhere but the United States where they use the more sensible Celsius system, If you tune into the radio or television, your temperature is probably given in Celsius, okay? But let's say you're an American and you don't really know Celsius very well because you're used to the Fahrenheit system, which is sort of a system that doesn't really make a lot of sense. But you go to Europe and you keep tuning into the radio and they keep telling you the temperature's in Celsius. And you go, I don't know what that means. Is that hot? Should I bring a jacket? Should I wear shorts? I don't know. I don't understand the temperatures that they're talking about on the radio. So you can convert those temperatures from Celsius to Fahrenheit using this, right? So what you would do, let's say they tell you it's 10 degrees. Yeah, say it's 10 degrees Celsius. So you would plug 10 in for C. You'd multiply by 9/5. So 9/5 times 10 would be 18. 18 plus 32 would be 50. So that's the same as 50 degrees Celsius. Okay, so 10 degrees Celsius is the same as 50 degrees Fahrenheit. So you go, oh, okay, that's kind of cold. I better wear some pants and probably bring a jacket, right? So that conversion can happen as is. Now, what if we wanted the formula written in a way that would convert Fahrenheit to Celsius? Maybe we want to go the other way. Maybe you're from Europe where they use Celsius and you come to the United States and every time you turn on the television, they're talking about Fahrenheit temperatures and you go, I don't know what that means, right? They use this silly system over here and you're trying to figure out what it is, right? So we want to solve this equation for the variable C so we get the conversion formula in its simplest form the other direction. So how am I going to do that? Well, the good news is you basically do what we did a moment ago. We're going to go through those linear steps of solving a linear equation, except this time it's a C and an F that are in there rather than, you know, the X that we were using a minute ago. Okay, so first thing I want to do, looking at this, there's no real like terms to combine. Okay. Well, why don't I use the addition rule? So why don't I subtract 32 from both sides? So we're going to go Fahrenheit minus 32 equals 9/5 C. Uh-oh, we got to compile there. Let's see if it fixes itself. There we go. Okay, so I subtracted 32 from both sides, and now I've got, it's a little bit better, right? We've got that C a little bit more isolated. It's a little bit more by itself than it was a moment ago. But now we have this fraction there. What are we going to do about that fraction? How are we going to get rid of that 9/5? Well, you could say, well, let's divide by 9/5. And that's true. We are going to divide by 9/5. But you may or may not remember there's kind of an easy way to do that division. And it ends up being by multiplying by the reciprocal of the fraction. So that fraction of 9/5, the reciprocal, it's just where you flip the fraction upside down. So if we flip 9/5 upside down, we get 5/9. So that's what I'm going to do. And I'm going to write it here because some of you may have forgotten this step or maybe you've never seen it before. We're going to multiply by the reciprocal, which for us will be 5/9. Now remember, all that is, that's a shortcut for dividing by 9/5. Multiplying by 5/9 is the same as dividing by 9/5, right? And that might seem weird at first, but you kind of already know this, right? Dividing by 2 is the same as multiplying by 1/2. And 2 and 1/2 are reciprocals. 2 over 1, if you flip that, you get 1/2. So you sort of already intrinsically know this for the simple situations like dividing by 2 and multiplying by 1/2. Those are the same. That's essentially what we're doing here. We're just flipping that fraction, multiplying by the reciprocal, and that's the same as doing the division. Okay? So when I do that, here's what I get. So I'm going to get the fraction 5/9, and we're multiplying the whole left side by 5/9, so that's f minus 32 equals, and now when I multiply 9/5 times 5/9, what do I get? I get 1. When you multiply a number by its reciprocal, you get 1. Why is that? Well, 9/5 times 5/9 would give us 45 over 45. Well, that's just the number 1, right? So in other words, we've isolated that variable. It's now just the c that we wanted. And now we have solved this equation for c. We started off with the equation being solved for f, and we solved the equation for c, and we're done. So that's really all there is to this formula bits, is it's the exact same tools that you were using previously for the, sorry, the Zoom's doing something new and it keeps distracting me. We started off with an equation that was solved for f, and then we solved it for c. Sorry, the Zoom has this new feature where if I put my hands on the screen, it starts thinking that I want to raise my hand or something, which is super distracting, but I don't. Let me see if I can turn this off here. They add these features sometimes which aren't really very helpful. Oh, here we go, reactions. Turn those off. And they're off. Okay. Okay, great. So that shouldn't be distracting me anymore. So that's how you solve for that equation. Does anyone have a question on how I did any of that? You're going to be given different formulas, but they're always going to say solve for A or solve for F or solve for whatever, right? And then you're just going to go through the same steps that you did for solving the equations, except now, you know, they're formulas. And so, like, occasionally I'll get a student that says, well, I don't even understand this formula. How am I supposed to solve for a certain variable? You don't have to know what that formula does. Right, like in college algebra, we do a similar thing, but with more advanced formulas where you have to do things that are a little bit fancier. And I had one student get all upset once because the problem in the book was E equals mc squared. And the student's like, I don't understand special relativity. How am I supposed to be able to solve this formula? You don't have to understand the formulas for special relativity in order to solve for one of the variables. You're still just using those basic math steps in order to solve for that, just like we did here. Okay, everyone good with that? Okay, then let's move ahead. That's really all there is to the formulas. But there's a endless formulas, so I can't show you every formula because there's, you know, thousands and thousands and thousands of formulas that we could use here. You just have to know those basic steps in order to do all of them. Okay. Where's this section I'm looking for here? Wait a minute. Sorry, I think I lost my place here. That's weird. Actually, let's just jump to I'll show you some stuff in, it's what I was going to do anyways. I forgot I didn't even need the book for this portion. Let's go into Delta Math. You're going to be doing a few different things here. So one of the things that you need to be able to do, and there's no memorization that I can give you. You have to think your way through this. Let me move this over a little bit so you can see it a little better. Is words to expressions, right? So how do we take words that are given in a problem and turn them into something we can use? And I know people don't like word problems, right? Word problems are right there after fractions, where people come to me and say, oh, I can do math except when it's fractions. And my response is usually, well, it's usually fractions. So if you can only do math when it's not fractions, then you can't do very much math. You have to learn how to do fractions, right? It doesn't really count for much because in real life, things don't come out perfect integers most of the time. It's the same thing with word problems. People come up and say, I just don't like word problems. I hate word problems. But if you think about it, outside of a math class, it's all word problems, right? All the math you're ever going to run across is word problems outside of a math class, because no one has someone come up to them and say, here's an equation, solve this, and then get back to me. That's not going to happen at your work, where your boss comes in and says, here's an equation, can you solve it and bring me the answer later? That's not how it works. What they're going to do is say, you need to figure out how many parts that our company needs to buy so that we can manufacture all the stuff we need to manufacture next month. And then you're probably going to have to do some calculations and figure out how many parts to buy, right? Well, that's essentially a word problem. So don't get locked into this thinking that it's only important that I know how to solve the equations. It's not important that I do the word problems, because the reality is, out in real life, you won't be able to do any math at all if you can't do word problems. So you have to kind of embrace it and go, I know it's not fun, it's not great, but it's really important that I know how to do these word problems, because that's the only way it's going to do any good for you. And most research shows, or the research shows, that by and large, the more mathematics a person can do, the higher paying job they're going to end up with, essentially. So, if you're in business, the people who can crunch numbers for business and, those people are going to get promoted higher than the people who can't really crunch the numbers. So if you're going to learn math, you want to learn it in a way that is useful. So part of that is being able to turn words to expressions. So let's take a look at that. What does this mean? So represent the following sentence as an algebraic expression where a number is the letter x. So they're telling us to use the variable x. In real life, it doesn't matter. In fact, in real life, a lot of times you're going to use a letter that makes the most sense for what you're working on, right? If you're working on a business problem, profit is probably going to be P. Revenue, probably going to be R. Cost, probably going to be C. It's a good idea to pick smart variables. That way, if you're dealing with a problem and you have R, P, and C representing price, revenue, and cost, or profit, revenue, and cost, you're probably not going to mix those up, because you're not going to go, I think R is my cost and P is my revenue, right? That would be silly. So we choose smart variables so that we don't mix things up. Here they're specifically telling us to use the letter X. Okay, so all right, let's look at this. Represent the following sentence as an algebraic expression where a number is the letter X. Okay, so they're saying a number is tripled. Okay, so tripled means to multiply by 3. So they're saying some number, some unknown number that we don't know, is represented, is going to be multiplied by 3. And look, they tell us in the problem we should be using the variable x. So that tells me this should be 3x. I submit. Yes, there we go. The way you take the words, a number is tripled, and you translate it into the mathematics is 3x. Okay, let's try another one. Okay, represent the following sentence as an algebraic expression where a number is the letter x. Now, I would encourage you to go slowly. It's very easy, and it's entirely likely that I'm going to do this because I'm sort of concentrating on explaining and teaching while I'm going through this, which sometimes distracts from being able to do the math. But you just want to break it down and go slowly, and look at the, just think about what these things mean, because it's easy to miss one and then you got to do a couple extra problems to get back where you were. So let's see. 8 is decreased by a number. Okay, so we know that when it says a number, that's our variable. Well, if there's some unknown, we're going to use a variable, right? Here they're making it obvious by saying a number, but it's not always going to be a number. It's just going to be an unknown value. We can use a variable to represent the unknown value. So if 8 is decreased by a number, 8 is decreased by a number. So here's the big question, and I see this is actually one that confuses people a lot. So the question is, should this be 8 minus x? Is that 8 decreased by a number? Or should it be x minus 8? That is a very common mistake when it comes to the subtraction. For addition, it doesn't matter, because if you add two numbers in a different order, you get the same thing. 5 plus 4 is the same as 4 plus 5. But with subtraction, we have to be more careful because 5 minus 4 is not the same as 4 minus 5. So I just want to I want you to take a second and decide, do you think that the answer is 8 minus x, or do you think that it's x minus 8? Just kind of say it in your head or say it out loud since you're all on mute. It won't really matter, but just sort of make a decision, right? Make a stand and say to yourself, which one do you think it is, 8 minus x or x minus 8? Because it's a commonly mixed up one. Okay, so looking at this, 8 is decreased by a number. So if we're careful there, just think about the phrase decreased by a number. If something is decreased by a number, that means I'm subtracting the variable. So this should be 8 minus x. Submit. Yes, got it right. Okay, so 8 minus x. If you thought it was x minus 8, that's okay. Just sort of be extra careful with that when it's a decreased by problem. Okay, be extra careful with it. All right, a number is doubled. That should be 2x. We're doubling some number. Do the next one. Twice a number. Okay, well, that sounds familiar. Twice a number, what would that be? Well, that should be 2x as well. So notice it's the same thing as the last problem, but with different wording. That's what makes this challenging about converting words into algebra, is that the English language is very rich. There's lots of ways of saying things that are essentially the same thing. And there's lots of ways of saying things that sound very similar, which are different from each other, right? So there's lots of different ways that you can say double something twice, right? Double it, multiply by 2. It's all the same thing. Okay, so that's how that one works. So you want to make sure you can do those. Do the words to expressions. Let's work at some that are a little bit harder. Words to expressions compound. So this means there's a little bit more to it. They're a little bit more complex than what we were just looking at. 3 is subtracted from the square of a number. 3 is subtracted from the square of a number. This is another one of those ones that's a subtraction. So you have to make sure you get them in the right order. So slow down and ask yourself, which thing should I be subtracting from what? So 3 is subtracted. So I'm taking 3 away. So I think I'm going to end up with a minus. Where am I typing? End up with a minus 3. Okay, so how do I represent the square of a number? Well, remember, our number is the letter x. How do I square that? There's 2 ways you can do this. One is if you hit x. In most software programs, the caret symbol is your exponent. The caret symbol is the one that's on the number 6. If you look like above the, between the above but close to the letters T and Y on your keyboard, if you look, that number 6 right there, see that little just looks like a little end of an arrow, that pointing upwards? That's called a caret. And in mathematics, that's usually used in software to give you a exponent. So if I put the caret in there, see how it went up to the exponent? You see that? Here, I'll do it again. So here I'm on the normal level. Here I use the caret. Now it's put me up there, and I can put a 2 up there. That's one way to do that. That's the short way. A lot of times, like here, I'll show you the graphical way. If we hit this keyboard over here, notice how it gives me the option for some exponents. You can use it that way if you'd like. So here's a squared, and here's a to a power. You can use those. So let's see if I get rid of that. And I go a squared. See how it put the squared on there for me? Or what if I wanted it to be cubed? I could hit that and make it cubed. It's whatever we want. And that's nice, having the graphical interface right here that we can use. But it's also nice to just know the shortcuts for stuff. So if you go caret 2, there I've got x squared minus 3. Hit submit. And I got it right. All right, let's try another one. The difference of 7 and the square of a number. Okay, the difference of 7 and the square of a number. So that one's a little, let's see. That one's actually worded poorly. When I write things, I actually specifically try to not write them in this way because this one is a little confusing. The difference of 7 and the square of a number. So same thing. Oops. 7 minus x squared. Got it. Okay. So you can see they break it down for you. The square of a number is x squared. The difference would be a subtraction. So you just go through those. Let's see what the next one's like. Okay. This one's a little bit trickier. So let's read this. 6 more than the product of 5 and a number. That's a lot going on there for that short phrase. Right? There's quite a bit there. There's 6 more indicates an addition. Product indicates a multiplication. So we got a few different operations going on here. Let's see. So 5 and a number. That's 5x. Okay, so where's my cursor? 5x. Okay. And then we want 6 more than the product of 5 and a number. So, well, 5x is the product of 5 and a number. 6 more than that would be plus 6. And there we go. We get that. You see how that is? Break it down into small phrases and then just keep introducing more and more of the phrase until you get to a representation of it that works. And there's the video, like always, there's the video in there. So you can go through and work on that, okay? So that is our words to expressions, both the simpler ones and then they call them compound ones. It just means there's more than one operation taking place. Okay, any questions so far? Okay, then we've got a bunch with ratios. So this may look like a lot, but notice, remember the way it works with the homework is I choose topics that go into a specific homework, and the default is that it makes you do 5 of those. Well, you have to get 5 points on those problems. But for ratios, there's a whole bunch of topics. Look at all of these. If I had you do 5 of all of those, I think when I set that up, when it was set to 5 as the default, it was like a 3 or 4 hour homework. So that was too much. So I reduced it down so you're really only doing 1 of most of these types of problems, which means you should be able to move through them a little bit quicker. But you want to make sure you're understanding the overall behavior of these. So they start off real simple, but then they do build in complexity. So they will get more difficult as you get to the later problems. So let's look at this one. Okay, find the ratio of squares to triangles in the diagram below. So here they're asking for the unsimplified ratios. When I looked at this problem earlier today, and they even have a hint, just count them all. I wasn't reading very closely, and I thought this said simplified. But then I got it wrong, and I went back. Oh, I wasn't even reading the directions very carefully. They want the unsimplified ratio. Okay, so unsimplified ratio, you're just counting them. A ratio is when we're comparing numbers of something. So the ratio of squares to triangles, see how they have squares first and triangles second? That means in your ratio, the squares should go first and the triangles should go second. So for us, this would be 2 to 4, right? Because it's two squares and 4 triangles. So where's my submit button? Oh, try. Okay, so then it's saying, all right, let's keep going. So for now it wants me to reduce the ratios. So we think of ratios like, in fact, a fraction can be interpreted as a ratio. So you would reduce your ratios the same way that you reduce fractions. So if we had the fraction 2/4, how would we reduce that? We would reduce that to 1/2. So 2 over 4 would become 1 over 2, right? Okay, so that's what we want, is that simplified version. So now if 2 to 4 was simplified to 1 to 2, then for every 1 square, there are how many triangles? 2, right? For every 1 square, there's 2 triangles. Therefore, the simplified ratio of squares to triangles is 1 to 2. And submit your answer. And there we go. We got it right. Does everyone understand what that is? So I know it looks different because you've got like pictures right here. And of course, there's the help video. But you can, we can look at it. Here's a big ratio. Find the ratio of circles to squares in the diagram below. So it looks like 1 circle gives us 1, 2, 3, 4, 5 squares. Okay. So the unsimplified ratio would be 1 to 5. Let's try that. Oh, whoops, sorry. I was looking at one line. It's really 3 to 15. I keep simplifying in my head when I shouldn't be. Okay. So for every one circle, there are 5. That's what I did a second ago. I simplified it in my head. Therefore, but I shouldn't have. I was getting ahead of myself. Therefore, the simplified ratio of circles to squares is 1 to 5. There we go. See how that works? See, that's working out for us. So that's how you do that problem. All right, let's look at level 2 ratios. Find the ratio of triangles to total shapes in the diagram below. So you really have to read the words, because a minute ago, like a lot of students don't read directions, they just plow ahead. You're going to keep getting this wrong if you don't read the directions, because you're going to, well, this is like the problem we just did a second ago. It's 1 triangle to 1 circle, or unsimplified would be 3 triangles to 3 circles, right? Careful, they're asking for the ratio of triangles to total shapes. So we can agree that I have 3 triangles, right, in that picture. But how many total shapes do I have? 6, right? There's 3 triangles and 3 circles, giving us 6 total shapes. So 6. So do you see how if you hadn't read the directions, you would just keep doing it wrong? And I get students that come to me and they do that. Like they'll be stuck on this part and go, I'm doing the same thing. It's telling me I'm wrong every time. There's something wrong with the program. No, you got to read the directions. You got to read carefully. Okay, so don't ever assume you know the directions. Stop and read them. So then we go try it. So it's saying for every triangle there is, so for each triangle there's 2 total shapes, right? For each triangle there's a triangle and a circle, which means that our ratio should be 1 to 2. And there we go. See? But do you see how that one little wording, we changed the word circle to shape, total shapes. And that changes the way that you do the problem. Okay, it changes that, so you got to look out for that. Okay, let's see what the next one looks like. Okay, but I just want to see, yeah, this is the same thing. So again, it's just total shapes. Wanted to make sure there wasn't something else coming up. All right, simplified ratio is basic. There are 6 squares and 4 circles. What is the simplified ratio of circles to squares? Now notice how, again, you have to read carefully. Notice how over here they told us 6 squares and 4 circles, so they told us squares first and circles second. But notice that in the question they're asking for the ratio of circles to squares. So notice that they're in a different order. You have to be careful about that. So the simplest, well, for us, the order would really be 4 circles to 6 squares, right? So if we reduce that in the same way that we would reduce a fraction, that 4 to 6 becomes 2 to 3. So 2 to 3. And we get it right. Okay? So you're reducing just like you do fractions. That is, you divide out any common divisor. So for this problem, they had 4 and 6 have 2 in common. So see how they have this? We're dividing by 2 on both sides to get 2 to 3. So for every 2 circles, there's 3 squares. All right, let's try another one. Oh, let's go back and do let's try one of these, simplifying ratios. Okay, now they're getting a little harder. 88 to 14. Wow. Well, just think of it as, what if this was 88 over 14 as a fraction? What would you do? You divide by 2 to get 44 over 7. I think that's all you can do with that one. So let's see, 44 over 7. Yeah, got it right. So it's just like, imagine it's a fraction and you're reducing it. You're doing the same thing here. You're dividing out any common factors. Okay. How about visualizing equivalent ratios? Okay, here we go. If there are 48 boys and 32 girls in a room, fill out all the possible ratios of boys to girls that can be made. So there, let's see. I'm trying to remember what they want for this one. Type in an equivalent ratio of boys to girls, but they're saying fill out all of the possible ratios. It's kind of a weird way of asking that question. So 48 to 32, I look at that and think, okay, well, I should be able to divide out an 8. So if I divide out an 8, that gives me, nope, we can do even better. 16. 16 goes into 32. 16 goes into 48. So if I divide that out, then there are 3 boys for every 2 girls. Let's try it. Ooh, it's got a nice little visualization there. Yep. Looks like that's what we did. Find another equivalent ratio of boys to girls. Okay, so it wants us to find different ones. So it really does want us to find all of them. Okay, so we found the most simplified one by taking 16 out. So what if we do, like I said a minute ago, what if we take 8 out? So that's going to be 6 boys to 4 girls. So 6 to 4. Try that. That's a pretty good setup they've got here. Yep, 6 to 4. Okay, that works. But there's more. What if we multiplied by 4? So we would get what? 12 to 8. See how it's just all the different. Here it's like all the different versions of a simplified fraction, except not fully simplified, right? Or one of them will be fully simplified, but we get all these different ones. So let's see. There's more. One more I'm missing. Let's see. What would we have? 3, 6. 4 we have, that's 12 to 8. So what if we multiplied by 5, 15 to 10. Okay, so we've also got 15 to 10. It's just different ways of representing that ratio with different amounts. Okay. Oh, right. So that one wasn't good. Let's see. Because it doesn't get us to the right number of boys and girls. Let's see. What would the last one be? Oh, we're kind of out of time here. There should be another ratio in there somewhere. Let's see. It would be... How could we simplify that? We divided by 16, divided by 8, divided by 4. Oh, 2. 2 would work. So for 24 boys and 16 girls. There we go. Got the last one. Couldn't think of it for a second. But we've got all the possible ways that that ratio can be. Oh, there we go. Someone got it for me in the chat. Yeah, good job on that. So, yep, there we go. So 24 to 16, we've got them all. And then it lets me submit my answer. There we go. Okay, so that's how that will go. So that's kind of getting started with the ratios. We'll talk more about ratios next time. Okay, we'll continue with this discussion about ratios, and I'll show you. I'll show you both how the answer works, like we'd started here, but then also some of these take a minute to kind of figure out what the problem really wants you to do. Okay, so as always, I'm going to close down the YouTube stream. Anyone who wants to chat with me or ask me questions is welcome to jump into the Zoom meeting and talk to me about whatever you need to talk to me about. Okay, you want to talk to me about a homework problem? Great. You want to talk to me about you're nervous about the class, you're not really sure how to do the homework, a homework problem doesn't make sense to you, you're not sure what they're asking in some of these weird problems, do that. So so come ask me questions. Just as a reminder, make sure you've done, a reasonable amount of work. I have to do those drops Wednesday and Thursday. So otherwise, thanks everybody, and I will see you in a couple